Welcome to Kenton's videos. Enjoy the video.
You start by powering and aligning the thermal sensor on the beak. This is critical because misalignment skews readings. Attach the module securely, then enable the live feed at 30 FPS for smooth output. Once the feed is live, set gain to 1. 0x and check that the central sensor pixel corresponds to the beak tip. Make small mechanical adjustments if needed. This ensures the system reads target temperatures rather than housing heat and prepares you for calibration. You now calibrate for accuracy. Perform a 2-point calibration using ambient air and a known 40 degrees C reference to linearize the sensor. Then set emissivity to 0. 95 for organic surfaces. If you see low readings, decrease emissivity in small steps. Once calibrated, map image pixels to beak coordinates so each hotspot corresponds to a physical location. Save that profile. Make sure to test by scanning a warm object across the beak axis to verify. You finish by operating with an overlay and logging. Set colorized thresholds so you instantly spot areas above your critical temperature. Log data at 10 Hz to capture dynamics and review any flagged spikes after sessions to understand trends. If you notice drift or inconsistent offsets, recalibrate immediately, inspect connectors for loose contacts, and verify the 3V rail is stable. If problems persist, replace the sensor cable. These steps restore reliable thermal readouts quickly and safely.
Thanks for watching. Consider subscribing if we helped you.